Hi all, this is lecture 22 on section 6.1, Introduction to Trig. Now before we get actually into trigonometry, which is based on triangles, we're going to talk a little bit about angles. Okay, so our first discussion here is going to be on the difference between a standard and a coterminal angle. Okay, so we're going to draw a little bit here because trigonometry is all based on geometry, okay? So we're going to start talking about circles. So if we think about looking at the coordinate plane, let's draw one here. This angle right here, we're going to think about as angle 0, right? So this is your starting place. All right, and then you're going to measure angles from here. So if I go this direction, I'm measuring positive angles. If I go in this direction, and let me change the color on that because red typically denotes negative, so let's pick blue. So if we're going this way, this is positive. And if we go this way, we're going negative. Okay, so that means what we call a standard angle is any angle that is positive, that is between 0 and 360. So this is 0, this is 90, this is 180, this is 270, and this is back all the way around would be at 360 degrees. Okay, so if you choose an angle that's between 0, that is less than 360, and greater than or equal to 0, that is a standard angle. So a standard angle is an angle between 0 degrees less than or equal to, and we're going to call it theta as the angle, is less than 360, right? Once you go to 360, now you're outside the standard angle, okay? Okay. Because 360 and 0 are exactly the same angle, okay? So that means, for example, if we wanted 30 degrees, we would go this direction 30 degrees. So this angle here, our theta, would be 30 degrees. Okay. Now, if I go 30 degrees the other direction, so if I went down here and this was 30 degrees, this angle right here is actually theta equals negative 30 degrees because you're going down. You're going to the right of 0. So that's the difference between positive 30 and negative 30. And the reason is this, because what we end up with is we want to talk about coterminal angles. So coterminal angles are angles for which you are located in the same position on your X and Y axis, okay? But the number of times you go around or which direction you go will change your angle measure. So for example, if I draw my 30 degrees down here, there's my 30-degree angle. However, if I go around a whole time and then all the way to there, that is now, the green one, is now 30 degrees plus 360 degrees. So that is now 390 degrees, okay, because you can go around the circle more than once. If I go around the circle twice, so all the way around, and stop at 30, then that's 30 plus 360 for the first time around, plus 360 for the second time around, and now we're at 750. Okay, so every time you add 360 degrees, it gives you a new coterminal angle, okay? But you can also go the other direction. So I can get that same angle placement here by going down first. So if I go all the way around here, then that angle would be 30 degrees minus 360 degrees. So that's 330 degrees, okay, because I went the other direction. And I could do that again, but go twice. So once, twice, and now I'm taking 30 degrees, which is my standard angle, and I'm subtracting 360 twice. So now I'm subtracting 720, which means that this is negative 690. Oops, I forgot my negative sign. All right, so this is negative 690. Okay, so standard means that it's between 0 and 360, and coterminal means it's the same position, but we're either adding 360 or we're subtracting 360. Okay, so we can go around as many times as we want. Okay, the next thing we wanted to, so for example, oh, and we just did this. For example, if we're going to find two positive and two negative coterminal angles to 30 degrees, what we would do is to find angle 1. We're going to take our 30 degrees and we're going to add 360 to it. And that's going to give us 390. Then to find angle 2, we want to be another positive. So we're going to take that 390 or take our 30 degrees and we're going to add 360 twice. So essentially we're adding 360 to our 390, and that's going to give us 750. Then if we want to negative, so angle 3, we're going to start at 30 degrees, but now we're going to subtract 360, and that's how we got our 330, negative 330. And then to get a fourth angle, we're going to start at 30, and we're going to subtract 360 twice. So now we're taking 30 minus 720, and that's negative 690. Okay, so two positives would be 390 and 750. And two negatives would be negative 330 and negative 690. Okay, so that's how we find our coterminal angles. Now, if you have an angle that's larger than 360 or that's negative, then if it's negative, you're going to add 360 to find the standard one. And if it's larger than 360, you're going to subtract 360 over and over again until you end up with something that is standard. Okay. All right, now let's talk about the difference between radian and degrees. So up until this point, every time that you measure an angle in geometry, you measure it in degrees. Okay, but in calculus, we're going to measure things and trigonometry, we're going to measure things in radians. And what we do essentially is we say, okay, instead of, and this kind of comes from the picture of a circle, right? So here's my circle, and the angles within that are 360 degrees, right? So 360 degrees. But if you think about, if we take the unit circle meaning that the length of the radius is 1, then the circumference, the distance around the outside, is the circumference of the circle is 2 pi r. And if our r is 1, then our circumference is 2 pi. So radians means that we're going to match up the number of the angle measure to the length of the curve on the outside, okay? And so what we do is we say, okay, we're going to take that 360, we're going to match it up to 2 pi radians. So 360 degrees is equal to 2 pi radians, okay? So if we're going to convert an angle measure from degrees to radians, here's how we would do that. We're going to use this ratio and set up proportions, okay? So if we are to convert, and let's pick something like 50 degrees to radians, what we would do is say, okay, I'm going to have degrees and radians, degrees on the top, radians on the bottom. And I'm setting up a proportion here. And I'm going to have the ratio, which is what we have above here, to my angle. Okay. Now, what I'm looking for is I'm looking to convert my angle to radians. So I'm looking for this spot, my angle in radians. And I know that my angle in degrees is 50. And then the ratio up here, there's 360 degrees in every 2 pi radians. And then you're just going to cross multiply this. So this just becomes 360x equals 100 pi. Now we typically with radians leave the pi in there. So then what we would do here is we're solving for x. We're going to divide both sides by 360. And just reduce that fraction as far as we can. So this is x times a fraction times pi, 100 over 36. If we divide 136 by 10 each, that's 10 over 36. And then we want to reduce that again. So those both have a 2, so that's 5 over 6 pi. Nope. 2 over 6 pi. Nope. If I could divide, this would go better. All right, so divide the top by 2 gives me 5. Divide the bottom by 2 gives me 18. So 50 degrees is the same as 5 over 18 pi radians. Okay, so let's practice that again. So in example 2, we're going to convert 60 degrees to radians and 5 pi over 6 radians to degrees. So I'm going to think about setting up my proportions. So I'm going to have the ratio and my angle in the proportion. And these are just labels to help me keep everything straight. The degrees I'm going to put on top, and the radians I'm putting on the bottom. If you can flip any of these positions that you like. Okay, let's see. I have 60 degrees, which is my angle. And I'm looking to convert that to radians, so my x goes in the radian spot. And then in the ratio, we have 360 degrees is the same as 2 pi. And then we can cross multiply. So this becomes 360x equals 60 times 2 pi. So that is 120 pi. And then we're going to divide both sides by 360. That gives you x is equal to 120 over 360. So reduced by 10 gives you 12 over 36 pi. And then 12 goes into both 12 and 36. So this is 1 over 3 pi, or what we would say would be pi over 3. Okay. Now there's a shorter way to do this, okay? Instead of using 360 over 2 pi, you could reduce this by 2. So this would be 180 over pi. Okay, so you can use that one as well. And so really all you're doing is either multiplying by pi, 180 over pi, or dividing by 180 over pi. But I like to set up the proportion and solve it properly so that we know exactly what we're doing. Okay, because then it works the same way going backwards for radians. So if I set up the same thing for 5 pi over 6 radians. Okay, so we have the ratio and my angle. And then we have radians and degrees. And it doesn't matter where you put these things as long as you have the 4 labels. Okay, in the ratio, the degrees is 2 pi. Sorry, the radians are 2 pi and the degree is 360. In my angle, I have 5 pi over 6, 6 pi. And I'm looking for the number of degrees. Okay. So now we cross multiply. So that means I get 2 pi x is equal to 5 pi over 6 times 360. Okay. Now, some things that I can do here before I divide. This 360 over 6, if you divide both of those by 6, it makes it 10. So this is going to give you 2 pi x is equal to 6 into 360 is 60. Times 5 is 300 pi. Did I do that right? I feel like I did not do that right. I did not. All right. 5 times 360 divided by 6 is 300. Now I did okay. All right, so we're good. Now let's go ahead and divide both sides by the 2 pi that's sitting in front of the x. When you do that, you get x equals, the pi's will cancel, and 300 over 2 is 150. There we go. Okay. So that's how we convert radians to degrees.